So here we go. We're starting chapter 5. We can call this unit 3. We're going to start by going back and looking at absolute value functions and how to graph absolute value functions. Absolute value functions, these pages can be found on Course Pack page 501. Absolute value functions and quadratic equations, the parabolas of quadratic equations, have some of the same concepts in the way that things move. So we're going to start by going over absolute values, and we'll go back to and we'll do parabolas, which is quadratic equations, which is what we're doing next. So general equation for an absolute value function looks like this. It's y is equal to a times the absolute value, oh lovely, of x minus h plus k. Remember, the absolute value sign itself tells you the absolute value of 5 is going to be 5. The absolute value of negative 5 is also going to be positive 5. So I end up with two answers for working backwards. If I have an absolute value is equal to 5, then the two numbers that will get me there are 5 and negative 5. So the interesting thing about this is, worst comes to worst, I can always go ahead, pick x's, pick y's, and pick x's, plug them in, find y's, and plot coordinates. But given an equation like this, if you haven't gotten out Course Pack page 501, stop, get it, fill this in as I'm going through this. This actually tells me stuff about my graph. First, the letter A. A is kind of seen as the slope. Now it's kind of weird because it's a positive and a negative slope depending on which direction I'm going. Don't want to use this all the time because it only works for absolute values, not for other things. Notice in my format here I have x minus h and plus k. The sign in front of the h is a negative. The sign out here with the k is positive. So I want the opposite of what's h and exactly what k is. So the vertex, the place I start, is h comma k. The other nice thing is I have an axis of symmetry, which is x is equal to h. So I have a line that goes straight down like this at x equals h. And that's my axis of symmetry. I'm going to move that up a little higher. X equals h. Now, what other information can I get from my generic equation y equals a times x minus h, absolute value of x minus h plus k? Well, if the graph opens up, if my a is positive, if my a is negative, it opens down. The graph is wider than the graph y equals absolute value of x if a is between 0 and 1, and it's narrower when the graph is greater, when a is greater than 1. For all of these, my domain will always be x is an element of the real number. All real numbers will work for my x's. I can always pick an x coordinate. I can always pick an x coordinate. It's always going to give me a y coordinate, but I can't always get a y coordinate. So that's kind of the basic idea of how these work, the domains. The ranges will either be y is less than or equal to k if it's facing down, or y will be greater than or equal to k if it's facing up. So write all these down, have them down. These are the different rules I need to memorize. Now I'm going to show how they're used. So let's look at number 1. The equation is y equals negative 3 times the absolute value of x minus 3 plus 2. First thing I want to know is what's my vertex. My vertex is the coordinate 3, 2. I want what's opposite on the inside for my k. for my h, and I want exactly what's on the outside for my k. So that's my hk. So I go to my graph, and I can plot the point 1, 2, 3, 1, 2. That's my first point. What is the effect of the value of h on the graph? Well, my generic, it moves my vertex as I was saying. What is the effect of the value of h on the graph? H is going to shift my vertex right 3. So it shifts right 3. Technically, it moves the entire graph, but the 3 deals with the vertex, so it's shifting to the right. So from 0, 0, I shift right 3. What is the effect of the value on k on the graph? Well, k shifts my vertex or my graph up 2 because it's a positive 2. So now that I shifted 1, 2, 3 right, I need to go up 2. And that's my vertex. The value of a, well, a is negative 3. Since it's negative, the graph opens down. Is the graph wider or more narrow than y equals the absolute value of x? Well, a is greater than 1, so it's going to be narrower or more narrow. The equation of the axis of symmetry is going to be x is equal to 3 my h. So I have my vertex. I have my axis of symmetry. X is equal to 3. I know I'm going to have a downward facing V. At this point, I can use the fact that A is sort of like a slope. Rise over 1 says I can go down 1, 2, 3, and right and left 1. Go down 1, 2, 3, right 1, down 1, 2, 3, left 1. Go down 1, 2, 3, right 1, 1, 2, 3, right 1, 1, 2, 3, left 1, 1, 2, 3, left 1. So that's going to give me my V shape, because I'm using that negative 3 sort of like a slope. Now, let's talk about my domain. My domain for absolute values is x is an element of all real numbers. I can always pick an x, can always plug in an x. It will always give me a value. However, my range, my y, is going to be greater than, I lied. For this one, since a is negative, y is going to be less than or equal to 2, my k. So that's my domain, that's my range, that's my graph, that's my vertex, axis of symmetry. I have it all there. That's how I graph one of these, by just looking at the equation. Let's look at this equation. Number 2. Y equals 0.5 x plus 2, absolute value of x plus 2, minus 3. Well, let's see, what can I do with this one? First of all, I'm going to say that 0.5 is the same as 1/2. It asks what is the coordinate of the vertex. The vertex is, again, I want h and k. I want the opposite of what's inside, so instead of positive 2, I need negative 2. And I need exactly what's on the outside, so minus 3. So my vertex is the coordinate negative 2, negative 3. If I go to my graph, I go left 2 and down 3. So there's my vertex. What is the effect of h on the graph? Again, that tells me that it shifts the graph left. Because it's a negative 2, it shifts left 2. Since it's a negative 3, it shifts down 3. That's the value of h and k. Since they're both negative numbers, they go left and down. What's the value of a? I can say that a is 0.5, or I'm the math teacher, I'm going to say it's 1/2. Does the graph open up or down? It's going to open up. Why? Because it's a positive 1/2, not a negative 1/2. Is the graph wider or narrower than y equals the absolute value of x? It is wider. Why is it wider? It's wider because a is between 0 and 1. Axis of symmetry is x is equal to the x coordinate, which is -2. So now I can come to my graph and I can say, okay, I have my axis of symmetry, which is x is equal to -2. I have my vertex -2, -3. I know that this is a V that opens up and it's wider than normal. I can use my slope as up 1, right 2, up 1, right 2, up 1, right 2, up 1, right 2, and do the opposite, up 1, left 2, up 1, left 2, up 1, left 2, up 1, left 2. When I do that, I'd get this V shape here. So what is my domain? My domain, as always, is x is an element of all real numbers. I can choose any x I want. My range, y has to be, since this is upward facing, it's greater than or equal to my y coordinate. My y coordinate of the vertex is -3. There is my domain. There is my range. Let's go to the next page and try number 3. Number 3, the equation is y equals the absolute value of x minus 1 plus 2. So what do I see? Well, first of all, the vertex h comma k, I want the opposite of what's inside, so I have 1. I want exactly what's on the outside, so it's 2. What's the effect of the h? Well, the h is going to shift. Since it's positive, it's going to shift right 1. What's the value of k? K is positive. That's going to shift up 2. Remember, h is with the x, so it goes left and right. K is on the outside like the y, so it goes up and down. What is the value of a? A is 1/2. Does it open up? That is not 1/2. That was the last problem. A is the number that's in between the equals and the absolute value sign. There's nothing there, but there's a hidden 1. So the value of A is 1. Since that's positive, it's going to open up. Is it the graph wider or narrower than y equals the absolute value of x? It's neither. It's going to be the same width as y equals the absolute value of x. What is the equation of the axis of symmetry? That's going to be x equals the x coordinate, which is 1. So I start with my vertex. Right 1, up 2. There's my vertex. My axis of symmetry is x equals 1. My slope is 1 over 1, so up 1, right 1, up 1, right 1, up 1, right 1. At the same time, I can go up 1, left 1, up 1, left 1, up 1, left 1. Go ahead and draw that line or that absolute value graph. It's my V shape. My domain, as always, x is an element of all real numbers. My range is y, it's facing up, so it's greater than or equal to my y coordinate, which is 2. I've done 3 examples off of that. Make sure that makes sense to you. Number 4 and 5 are going to do the opposite. Write the equation of the absolute value function for the graph shown below. I want to work backwards on this. So I'm going to start with my graph. It's upward facing, so I know that A has to be positive, greater than 0. My vertex is a coordinate 2, negative 3. So I'm going to start with the equation y is equal to a times the absolute value of x minus h plus k. And I need to plug in 3 points, a, h, and k. I know that h is 2. I know that k is negative. That's not a negative. That is negative 3. The other point, to find my a, I have to have another point. So for this one, I have the point 4, 1. So the absolute value function is y is equal to a times x, a times the absolute value of x minus my x coordinate of the vertex 2 plus the k, the y coordinate of the vertex. It's a negative 3, so plus a negative 3 is minus 3. Now I need to find my a. There's 2 ways of doing it. I'm going to show you both. The first way is to come to my equation and say I have the coordinate 4, 1. Y is 1. A is missing. X is 4. I can solve for that a. So a times 4 minus 2 is 2 minus 3. 1 equals a. Absolute value of 2 is 2 minus 3. So I'm going to add 3 to both sides. I get 4 is equal to 2a. So a has to be 2. So my function is y is equal to 2 times the absolute value of x minus 2 minus 3. My domain, as always, x is an element of all real numbers. My range is y, since it's facing up, is greater than or equal to my y coordinate, which is negative 3. Now, I said there was another way to find that a. Well, how do I find that a? Well, if I start on my graph and I rise 1, 2, 3, 4, I'm going to run 1, 2. So I went up 4, right 2, which is 2. Now let's say my point was over here. I would run up 1, 2, 3, 4, and right 2. That would, and left 2. That would be 4 over negative 2, which is negative 2. But since it's absolute value, I would just call that 2. Does this work? Yes. Do I like that it works? No. I personally would prefer that you use this method over here, but they both work. So I'm not going to kill you if you know something different. Last example. Where are we? We are at 18 minutes, so I'll try to go quickly. My vertex is the coordinate negative 2, 1. The other given point is the point 1, negative 1. I know I'm going to use the equation y equals a times x minus h plus k. A times the absolute value of x minus h plus k. So I need to go ahead and, by the way, since it was facing up, I knew that a had to be 2. If it's facing down, I know that a has to be a negative number. So when I plug this in, I'm going to go, and if I do this the quick way, here's the point 1, negative 1. Here's the point negative 2, 1. I'm going to go down 1, 2, and right 1, 2, 3. So that was down 2 and right 3. So my absolute value equation, we said, would be y is equal to a times x minus a negative 2, which is plus 2, plus 1. Plug in the point 1, negative 1. So negative 1 is equal to a times 1 plus 2 plus 1. So negative 1 is equal to a times 3 plus 1. Subtract 1 from both sides. Negative 2 is equal to t. The absolute value of 3 is 3. Divide both sides by 3, so a is equal to negative 2/3. If I did it up here, or if I did it over here, I still came up with the same a. Y is equal to negative 2/3 times the absolute value of x plus 2 plus 1. My domain, as always, x is an element of all real numbers. My range is y, since it's facing down, is less than or equal to my y coordinate, which is negative 1. I lied, which is positive 1. Those are my examples. We are at a little over 20 minutes. I will see you later.